Okay, I'd like to demonstrate how I deal with large-scale noise in my astrophotography shooting with a DSLR camera. And the DSLR cameras, like the Canon or the Nikons, of course, use a CMOS sensor, and the CMOS sensors are a little more less quantum efficient, therefore they produce a lot more noise in your images, even with calibration frames. So I'm going to open up the Flaming Horsehead Nebula, the image I took recently. I'm going to run real quickly through some processes here so I can just show you. Do my automatic screen stretch. Now this is in the this is in the linear state, so this is not a permanent stretch. This is purely for visual use. Let me go ahead and crop out some data that's missing here on the edges. I'm not really going to be, this is not an image I'm going to be saving, I just wanted to show you. So of course, there's a lot of noise associated with this image, and you can see it's not horrible, but it can be fixed. And there are two, I think, great noise reduction tools within Pixinsight that A, you use one in the linear state, and then B, use the other in the nonlinear state. So first, let me run through the linear state, which we're in right now. And for the linear state, I like to use what's called the A-true wavelets, A-true wavelet transform. And for this, we need to create a mask to protect our high signal area. Now, normally I would run through by dynamic background extraction. I would neutralize the background and go through color calibration. So this image is not calibrated as it should be, but I just want to demonstrate noise reduction. Let me duplicate the image. Let's select it as a mask. And let's invert this to protect high signal areas. For layer 1, I like to use a threshold of 4. For layer 1, let's use 3. This is pretty much a common thing for people who use Pixinsight, these parameters here. For layer 3, let's use 1. And then for layer 4, we'll use 0.5. And going back to layer 1, let's reduce our amount to about half. And we'll do that for each layer. What you'd ideally want to do is, instead of cranking up the amount, if you need more noise reduction in the large scale areas, crank up your iterations, especially on the first layer. So for the first layer, I'm going to crank my iterations up to 3. For the second layer, 2, and then leave it on 1 for 3 and 4. Let's go ahead and apply this instance. And once it gets finished, I'll show you the results. It really is impressive. Okay, A-true wavelets has finished, and as you can see, it smoothed out the background large-scale noise pretty well. Let me undo it so you can see the difference. So there's the before. I'm hoping you can see that, and let's redo it. So this is a great large-scale noise reduction in the linear state. Now let's move on to the nonlinear state. Let me remove my mask. Exit out of here. And like I said before, this image is not color calibrated or anything. Ideally, I would not want to move into the nonlinear state without doing color calibration. But I would really just like to demonstrate the power of the noise reduction tools in Pixinsight. Let's go ahead and reset our screen transformation function. And let's get rid of that. And let's open up histogram transformation so we can move into the nonlinear. Let's track our view. Let's give it a good stretch. This by no means is stretch. Let's go ahead and clip our dark point. And to quicken this process up, you can use the screen transfer function to apply it directly to the histogram transformation. I'm just kind of running through this real quick just to show how this noise reduction works. Okay, we're almost there, and like I said, I want to reiterate. This image is not color calibrated, so you can see my red, green, and blue channels are not perfectly aligned. But that's okay. Okay, let's stop there and let's zoom in here and let's move into the nonlinear noise reduction. And the tool we will use is the AC DNR noise reduction tool. And instead of duplicating our image and making a mask, we can make a mask within the AC DNR tool. Make sure lightness mask is checked, and both for chrominance as well. Moving back to the lightness tab, move down to the lightness mask at the bottom, click preview, click on the circle here to open up your preview window. And of course the white areas are where the noise reduction will be applied the most to the low signal, and the dark areas is protecting the high signal area. Now the horse head is light because it's dark, so it thinks it's low signal area, but it is something that you might want to consider. You could darken up the horse head so you don't smooth it out as much. But the point of using preview is you can change your midtones or your shadows as such to apply heavily where you want for large scale noise reduction. And I think I want to apply pretty heavy in the background, and that looks pretty good. Let's go ahead and uncheck the preview. Let's exit out of this. Make sure apply and lightness mask are checked on both tabs. Leave everything in the default setting except for standard deviation. Because I do have quite a bit of large scale background noise, I'm going to crank up my standard deviation on the lightness, and I'm going to crank it up even more in the chrominance by almost a whole point. So 4 and 5 for both. Let's go ahead and apply the instance. It takes a few minutes to do this, so once it finishes, I'll come back and I'll show you the difference between before and after. Okay, AC DNR has completed its noise reduction. Let me zoom in and show you. So here's the after. Let me undo and show you the before. There's the before. You should be able to see that. Let me redo. Smoothed it out really well, and it's kept the high signal areas like these black bright stars without smoothing them out too much. So that is noise reduction in the linear and nonlinear state in Pixinsight. Great tools, both the A-True wavelets and the AC DNR. I'll go ahead and throw a comparison picture up to close this video out. Thanks for watching. Please comment and like, or ask me if you have any questions.